Hello guys, welcome to Deep Codes, and in today's video we will discuss Lit Code question 953 that says verifying an alien dictionary. So here we are given an alien language and that consists of English lowercase letters, but the orders are different. So we are here given one ordered string that represents the order of letters in the alien dictionary, right? Instead of ABCD they have different orders. And further we are given some words here in this vector of string, and we need to identify whether the words are ordered in sorted or not. See, we are given the sequence of words, right? And there is the order of alphabets. So we return true if and only if words are sorted lexicographically in the alien language. So based on this sequence, are the words sorted or not, that we need to check. And if they are sorted, then we will return true, else false. Okay, now let's take a look at this first example. So for this, there are only two words. So we check for characters. First character of both the word. Here comes the H and then L. So as you can see here, H comes before L. That means this word should come before this word, right? And hence this word's vector is sorted. So we return true. Okay. Now let's take this example. So let's first check for these two words, first two words. So WW is same, O and O is same, R and R is same. Now comes here it is last letter is D and here the letter is L. So as you can see here, L comes before D. So this word should come before word, right? And that's why we written false here, because L comes before D and here the fourth character specifies that this word should come before. Now let's take a look at this example. Here everything is same up till APP, right? So after APP the words ends here. So this should come before this word. It is as simple as that, right? Regardless of the sequence, everything was same, and this word has some more characters. So that's why this should always come after this, and so we return false here. Okay. Now thinking about this, we see guys, we don't have to sort this word, all these words, right? We only need to check whether they are sorted or not. So let's say, let me take one example. So let me show you by taking the help of numbers. Let's say you have numbers like 1 2 3 3 5 7 6 1 8 9. So if in order to check whether the numbers are sorted or not, what you can do, either you can check this 12 with all the numbers, then 33 with all the numbers, 57 with all the numbers, or what you can do, you can check if 12 and 33 is sorted. If this is true, then you can check ahead, 33 and 57, is they are sorted? True. These two are sorted or not? True. These two are sorted or not? True. So if you check adjacent element, and if all are true, then you will return true. If somewhere it is false, then return false, right? So here also in the words variable, we will check the adjacent element, and we will check whether they are sorted or not, right? Okay, these things are clear till now. Yes. And if there is something like this 1 2 1 and 1 2, so as you can see here, this 1 2 1 should come after this 1 2, right? So in this case we will return false, as we saw in this last example, that this app and this is apple. So apple has some more characters after APP, so it should come after APP, right? So that's why what we noticed till now, that we will check adjacent character or adjacent elements or words for are they sorted or not. And if a word I plus 1 ends, then also return false, right? This is like this: if I plus 1 word and there are some more characters in the ith word, then we will return false, correct? And yeah, and something like this, let's say if these two comparing these two, if we found a character where let's say this first character is less than the second character, we would break. If let's say word of I and J, that means the jth character in the ith word, if it is what we can say less than word of I plus 1 and jth character of I plus 1 I plus 1 word, then what we would do, we would simply break and check for other words. And another thing what we need to do is, if word of I, that is the ith word with j character, is greater than I plus 1 word of jth character, then what we would do, we would simply return false. Case like this, if we have 57 and here it is 37, so this 5 is greater than 3, so it should come ahead after this, right? But it is at the ith index and this is I plus 1 index, so this is not sorted, so we would simply return false. So based on these simple conditions only, what we would do, we would treat it either true or false. So I hope you guys are clear till now. The only thing remaining is we need to store the sequence, right? So what we need to store this order sequence, and this we can use either unordered map, or we can also create a vector of size 26, because this is of size 26, a fixed length. So yeah, in order to check this, if it is less than or greater than, this is checked based on the occurrence of the sequence in their dictionary, alien dictionary, and that we would do by helping with writing in a help with an unordered map or a simple vector of size 26. So yeah, that's for the approach part. Now let's begin to the coding part. Okay, so let's start by creating one vector. Let me name it as a sequence that is of size 26 and 0. So here for each character I will store some numbers. Okay, let's say for H I will store 0, L I would store 1, A I would store 2. So that's way I would store it's a priority, right? You can say this is a priority based on their alien dictionary. Order dot size and sequence of order of I minus A equals to I. Correct. Now what we do, we would traverse this words array, and we are checking the adjacent word, so we will travel only till the last second word, right? And for each character in the word, it's less than word, words of I dot size j plus plus. And now this condition that we have discussed, what is the first condition? If a word of I plus 1 ends, that means if a j is greater than equal to words of I plus 1 dot size, that means we would return false here. Okay, now we have to check for these two conditions, but before that let me take the current two characters, the character of the word I, the jth character of the word I, that is words of I j, and the another character c2, that is a character of I plus 1 word. Now we would check if c1 not equal to c2, that means both the characters are different, and sequence of c1 is greater than sequence of c2. In that case we would return false, because according to the sequence this this character should come after this, so this word 1 should also come after this word, right? Now similarly, if these two are different, both the characters, and sequence of c1 is less than sequence of c2, okay, then we are good. What we would do, we would simply break. There is no need to check for ahead word. As you can see, the first word H is has less priority than L. Then we won't check for other characters, right? Other ahead characters. So the only thing remaining where this for loop will run is when both the characters are same, because we have the condition if they are not same, right? So if they are same, then we would check until we found any, and if until any of the conditions are hit, right? And in the end we would simply return true. That means all the false test cases are already covered here. So now let us try to run this. Okay, it is going some error. So y dot size, what's dot size of y dot size? Okay, here it would be sequence minus, because since this is we are stored right this way, so we also need to take this way only, right? Yeah, let us now try to run this. Yeah, so the test cases are passed. Let us try to submit this. Okay, yes, so as you can see our code got accepted. So yeah, that's for the approach and the coding part. Now let's talk about the time complexity. So our time complexity runs for all the words. So let's say there are m number of words, okay, and inside the words it run for characters. So but as you can see, how many maximum character it will run? It will run for at max 26 characters, because after that, after comparing all these 26 characters, it will end, right? So overall, what you can say, overall the time complexity would be equal to m, that is the size of this word string, right? And talking about the space complexity is also is big of fun because this is of a fixed size sequence. This is only thing which we are storing, and it is of a fixed size. So we can say the space complexity is big of fun. So yeah, that's all for this video. I hope you guys understood this approach part as well as this coding part. um, so if you have still any doubts, then let me know in the comment section. And one thing to note here is that I'm posting the opportunity or the job openings in the community section, so make sure you check that out. And apart from that, yeah, do subscribe the channel. It helps me to make such videos every day. So yeah, please make sure that you give a like to this video and subscribe to the channel. Thank you.